Hello students, how are you guys doing? I hope you guys are doing okay. I will be going over lesson 6.3, building quadratic functions from geometric patterns. This is Wednesday's lesson. Our learning targets are, I can recognize quadratic functions written in different ways. I can use information from a pattern of shapes to write a quadratic function. And I know that in a pattern of shapes, so we're looking at shapes and what patterns they make, the step number is the input and the number of squares is the output. This is probably one of the most important parts of today's learning targets, that the step number is the input and the number of squares is the output. So for your warm-up, you guys will be working on this assignment. And this assignment says quadratic expressions and area. Figure A is a large square. This is figure A. Figure B is a large squared with a smaller squared removed. So figure B is the same thing as figure A, but they remove this little piece here, this little square. Figure C is composed of two large squares with one smaller square added. So figure C is these two large squares with this little small square added at the end. The question says, write an expression to represent the area of each shaded figure when the side length of the large square is as shown in the first column. So this table gives us the side length of large square. So the side length of the large square. They want us to find the area of this square, the area of this square, knowing that this piece has been removed, and the area of this figure here. Right now, you will work on finding the first. So you're going to be finding this, this, and this, and you will type in your answers when prompted. Okay, so now let's go over this warm-up. So here we know that we need to figure out what the area is of figure A if our side length of the square is 4. So if we know that this is 4, because this is a square, all 4 sides are equal, this side will be 4. And we know that the area of a square is always the base times the height. So if we multiply base times height, we would get 16 as our answer, because 4 squared is equal to 16. So they want us to write it as 4 squared in this case. For the area of B, you know that this side is 4. You know that this side is 4. So we know that the area would be the base times the height, so 4 times 4, which is 4 squared. But now we are removing the area of this square. So if we remove the area of this square, we would have to first find the area of this small square, which would be base times height. So the area of this square would be 1. So the area of this entire figure would be 4 squared minus this area of this small squared, which is 1. So we get 4 squared minus 1. Now the area of this figure will be, well, we know that this squared has a side length of 4. And this side length is 4. And we know that this side length is 4. And we know that this side length is 4. So if I wanted to find the area of just this piece of the figure, this would be 4 squared. And if I wanted to find the area of this piece, it would be 4 squared. And what am I doing to this little small piece, this little small squared? We are adding it to this figure. So the area of figure C would be 4 squared times 2, because there's 2 of these figures, plus the area of this small squared, which is 1. Okay, so now I'm gonna stop the video and you guys are gonna figure out what would be filled out in this section, and in this section. I will stop the video now. Okay, so now that you guys have tried it and you answered it on your own, let's go over it. Following very similar to what we did in step 1, we will now figure out what the area would be if our side length was x, okay? So if we know that our side length is x, then this side would be x, this side will be x. So what would be our area? Well, the area of a square is base times height, so x times x will give us x squared as the area of the figure. In this problem, we are always removing this square. This square always has the area length of 1 because of base times the height. So the area for figure B would be x squared minus this one. And following the same process as the first step, we know that these side lengths are x, so the area of this would be x squared. The area of this piece would be x squared, and we know we're adding this area, which is 1, so we have 2x squared plus 1. So now it gets a little bit more difficult. So what will happen if we now have a side length of 4x? So if this side is 4x and this side is 4x, what would be the area of B, of A, B, and C? All right. So in order for us to be able to determine the area of A, if the side length is 4x, we would multiply 4x times 4x, and we would get 4x to the second power, or 4 times 4 is 16x squared. Now, what would be the area length or the area of square B? That would be following the same pattern. It would be 4x squared, and we always subtracting this one. And what would it be for this figure? It would be 4x squared times 4x squared plus 1. So we would get 2 times 16x squared plus 1. Okay? And finally, if this side length was x plus 3, how would we determine the area of figure A, figure B, and figure C? Well, very similarly, following the pattern that we have established here, if this side is x plus 3 and this side is x plus 3, our area to this square would be x plus 3 times x plus 3, or we could just rewrite it as x plus 3 squared. Remember that anytime it has a square, you can put that twice as x plus 3 times x plus 3. If we follow the same pattern, we know that it would be x times 3, x plus 3 times x plus 3, minus the area of the small figure, which is 1. And similarly, we have 2x plus 3 squares. So we have 2x plus 3 squares plus 1. For this activity, you are expanding the squares. So you're given step 1, step 2, and step 3 and the shape of these figures. Question says, if the pattern continues, what will we see in step 5 and step 18? So based off of these figures, we need to be able to determine the following steps: step 4, step 5, step 6, step 7, etc., etc., etc. So what they want you to do here is sketch or describe the figure in each of these steps. Now, we can't really sketch because you cannot sketch these figures into this program. So what I want you all to do is, as best as you can, describe in terms of what step number and the total number of squares in each step for step 5 and for step 18. Okay. So you had an opportunity to type in your answers. Let's go over it. So step 5 has a total of 29 squares, and it has 29 squares because if you look at the figures, you can see that the inside square of each figure follows a specific pattern. And this pattern can be made by looking at the step number of each figure. So, and if you notice, it has 4 corners. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 in every single figure. Steps 18. Oh, and before that, so we have basically, I drew this out for you. And if you can tell, because we're talking about step 5, it has 1, 2, 3, 4, 5 columns and 1, 2, 3, 4, 5 rows, which matches the patterns made by these figures. Step 18 will have a total of 328 squares and 324 in the center with the 4 corner squares added to it. So now that we have described the figures for step 5 and for step 18, how many small squares are in each of these steps? Explain how you know. All right. So now that you had an opportunity to talk about how many small squares are in each steps. So step 5, we kind of already had the answers here. There would be 29. And the way we broke down yesterday's lesson, we can determine that step 5 has 29 because if we figure out that there's 5 rows and 5 columns, that means that there would be a total of 25 squares in the center plus the squares that are added at the corners. And this is how we have our expression 5 squared plus 4. For the step 18, we would have very similar. So 18 squared, because it would have 18 rows and 18 columns in the center plus the 4 on the corners. The next activity, expanding squares, we're using the same figures, but now we want to write an equation. And this is the main idea for today's lesson. So write an equation to determine, to represent the relationship between the step number n. So this is very important. Here, they're telling you that the step number is n. So all these numbers are the step number. And what we want to do is also find the number of squares, and we're labeling those y. So our inputs would be the step number, and our outputs would be the total number of squares. It says, be prepared to explain how each part of your equation relates to the pattern. If you get stuck, try making a table. And the table is probably the best way how to visualize these figures and determining the equation for the future steps or the step number n. So in order for us to do this, I'm going to help you with creating this table. What I want you to do right now is I want you to fill in the rest of the table. You're going to write for step 1, which is basically this figure here. This is step 1. I want you to fill out how many squares are inside, how many corners, and how many total. And you're going to do the same for step 2, for step 3, for step 4, which is not given, but follow the patterns that you have established. And you are going to then fill out the information for step n. Once you are done typing your answers, we will review them when you return to the video. Okay, so now that you have inputted your answers. Inside of square one, we only have one square. How many corners? We have 1, 2, 3, 4. And how many total squares do we have? We have a total of 5 squares. So here you can start noticing the relationship between the inside squares and the corners and the total number of squares. For step 2, we have a total of 1, 2, 3, 4 inside squares. We have 4 outer squares, which gives us a total of 8 squares. For step 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or an easier way would be understanding that if we have 3 columns and 3 rows, to find the total, we multiply the columns with the row and we get 9. So we have a total of 9 inside squares, and we are adding 1, 2, 3, 4 more corners of squares, which gives us a total of 13 squares. Okay, now based off of these numbers here, we're going to try to see if we can figure out how many inside squares step 4 would have. Well, if you notice that the inside, we have 1 row, 1 column, so we have a total of 1. In the second, we have 2 columns. We have 2 columns. We have 2 columns. And we have 2 rows, which gives us a total of 4 inside squares, and the same thing for 3. So by looking at the pattern, we know that inside of step 4, we're going to have 4 columns and 4 rows, which gives us a total of 16 inside squares. And following the pattern, we have always a total of 4 corners. So if we have 16 inside squares and 4 corners, we have a total of 20 squares. So based off of this information, you were supposed to have inputted what the number of squares a figure would have in step N. Well, if we notice the relationship between rows and columns and the step, if step 1, we have 1 column, 1 row. In step 2, we have 2 columns, 2 rows. In step 3, we have 3 columns, 3 rows. And in step 4, we have 4 columns, 4 rows. So in step N, we will then have N columns and N rows, which will give us a total of N squared inside squares. So how many total corner squares? If we follow the pattern, there would be a total of 4. So what relationship do we have between the inside squares and the corner squares in the total? Well, if we add the inside squares plus the corner squares, we get the total. So in order for us to be able to determine how many total squares step N would have, I would have to add N squared plus 4. And that's going to give us, well, since you cannot add a variable with a number, we leave it as N squared plus 4. So in question number 2, write an equation with the total number of squares representing y. Our equation would be y equals N squared plus 4, where the N squares represent the number of small squares in the center, and the 4 represents the 4 corners in our figures. Okay, for number 3, it says sketch the first 3 steps of a pattern that can be represented by the equation y equals N squared minus 1. Input your answer now. Okay, so now that we're back, in this problem, we know that N squared represents the inside squares, and this minus 1 represents how many squares were taken away. If you look at these patterns, we know that the N squared represents the number of squares in the center of the figure, and this plus 4 represents the 4 corners. Well, in this equation, we have a -1, which means we're taking one square away from the n squared, the center. So an example would be if I have n equals 3, meaning step 3. This case, if I were to substitute the 3 in my n, I would have y is equal to 3 squared minus 1, which equals to 9 minus 1, which will have a total of 8 squares. And to understand what that would look like, we would have this 3 by 3 squared because n equals 3. So 3 columns and 3 rows. But since we're subtracting 1 square, what we do is we delete this corner, and this would be our figure for this equation here, y equals n squared minus 1. For our last problem, growing steps, we have another figure similar to the previous, but drawn differently. In step 1, we have a total of 3 squares. In step 2, we have a total of 2, 4, 6, 8 squares. And in step 3, we have a total of 3, 6, 9, 12, 15 squares. Problem 1 says sketch the next step in the pattern. I'm going to give you a time to not sketch, but describe what the next step will look like. Do that now. Okay, so now that you attempted to describe the next step, I'm going to provide you the next step. And if you notice here, step 1 had one column, 3 rows. Step 2 has 2 columns, 1, 2, 3, 4 rows. Step 3 has 1, 2, 3 columns, 1, 2, 3, 4, 5 rows. And step 4 has 1, 2, 3, 4 columns and 1, 2, 3, 4, 5, 6 rows. Question number 2. Karen says that the pattern is growing linearly because, so I'm going to highlight linearly because we have learned that a pattern that is growing linearly represents a certain situation. So continue. Karen says that the pattern is growing linearly because as the step number goes up by 1, the number of rows and the number of columns also increase by 1. Do you agree? Explain your reason. You have time to answer this question now. Okay, so you were supposed to either agree or disagree that the steps are following a linear pattern. Karen is actually correct that the number of rows and the number of columns each grow by 1, but the total of number of squares does not increase by the same amount from step to step. So the total number of squares does not grow linearly. So Karen is actually wrong. Even though it is growing an extra column and 1 more row, we are not growing by the same number of squares. Step 1 has 1, 2, 3 squares. Step 2 has 2, 4, 6, 8 squares. Step 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And because this number is not growing by the same number, 3, to get from 3 to 5 to 8, we add 5. To go from 8 to 15, we add 7. So in order for, it's not growing by the same number, so it is not a linear function. Question number 3. To represent the number of squares after n steps, Diego and Jada wrote different equations. Diego wrote the equation f of n is equal to n parentheses, which means times, n plus 2. Jada wrote the equation f of n is equal to n squared plus 2n. Are either Diego or Jada correct? Explain your reason. You have time to provide your answer now. Okay, so now that you had an opportunity to determine whether Diego or Jada is correct, the best way that I can explain how Diego got this equation n parentheses n plus 2 is by providing you with the table. In this case, the step number would be the number of in the pattern, and we're looking for the nth step. That's why Diego and Jada both use the variable n. In order for us to determine that, we need to find how many total bases and height we have and the total number of squares. So in this case, our base would be 1 and our height would be 1, 2, 3. And if we want to know what the total is, we count 1, 2, 3, or we multiply 1 times 3, and we get there's a total of 3 squares. For step 2, there's a total of 2 for our base, 1, 2, 3, 4 for our height. So if we multiply 4 times 2, we get 8. Step 3 has 3 as our base. We have 1, 2, 3, 4, 5 as our height. And how many total squares do we have? We have a total of 15. And finally, step 4, well, step 4, we're not worrying about step 4 because now we can actually find what our end step would be by following the patterns. What do you notice? Well, if you look at step 1, we have 1 as our base, 3 as our height, and that means a total of 3 total. If we have 2 as our step and 2 as our base, if our step is 2, our base is 2. If our step is 3, our base is 3. So if our step is n, what would be our base? It would be n because these numbers are exactly the same. Now, what is the relationship between 1 and 3? Our step and our height. Oops, you did not see that. So what is the relationship between 1 and 3? What is the relationship between our step and our height? What is the relationship between our step and our height? So in step 1, our height is 3. In step 2, our height is 4. In step 3, our height is 5. So you should notice that our step is always 2 less than our height, meaning that if we add our step plus 2, I will get our height. 2 plus 2 will give us our height. 3 plus 2 will give us our height. So if our step was n and I wanted to find our height, we would follow that pattern and we would have n plus 2 be our height. Now the relationship between our base and our height and the total number of squares is if we multiply 1 times 3, we get 3. If we multiply 2 times 4, we get 8. 3 times 5, we get 15. So if I were to multiply n times n plus 2, I would get n times parentheses n plus 2, which is what Diego wrote as his expression. Diego's expression n parentheses n plus 2 is correct because there are n columns and n plus 2 rows of small squares. Now, is Jada correct? Well, Jada is also correct because if you distribute the n outside of Diego's equation, you get Jada's equation. So this is Diego's equation, but if I were to multiply n times n and then n times 2, you would get n squared plus 2n, which is Jada's equation. Okay, hopefully you understood that. Now, what you need to do is you need to go back to Schoology and complete the coda. Good luck, and I hope you understood today's lesson.